And this is a big idea. It is the big idea.
Sitting here on lunch break. So we got ourselves a little order, mixed bag, number, feel.
Made up.
We need certain pieces, certain sizes.
Instead of memorization, it's
basically play it like a linear footage order. Get your either work your tally sheet. You know, make your tally as you're going, or actually have one on Excel.
Remember,
you know, that's a lot of this, guys, right here.
And we use
beautiful
solutions to subproblems.
Beautiful stuff. It's gorgeous. But as we're doing that, right now it's hands on deck for that one. Get that one knocked out real quick. Which I only got a couple of one-bys done. But as I'm chasing for 36, 36s, we'll be doing 24, 48s later, blue thermal pattern, and big dogs. I already got one of them done, and those are these guys over here, racking them and stacking them. Here I'm knocking back some 17 ones that I need to finish that B&B. So to set something like that up, you know, we're talking about the particle accelerator here. You know, well, you got your pallets and how you want to set them up in a mixed bag like this, but also here I'm running in sets. You know, this is really nice stock. So this is going to come in burning real nice. You're going to stack these up. But as you can see, I got them laid out. You know, 4 is my set. I like that number. Stacks real good. I don't have to worry about changing blades or you know anything like that. I can throw a 3 set down on it, and that'll keep it running. If I need to split something out, this is my split back pile. And what I'm doing with this is this should be pretty decent material, but I'm not going to make the 3. So I'm not going to make the bigger hits. And so these might be single turns. That's this over here, but you can do that with these. These are single turns. Set them up to the table one at a time. Is there a better pattern cut for it? Where I'm going to get a higher volume out of this piece. You know, you're splitting down what stacks up at, you know, into a double set like that. You know, obviously I got my good singles. I know these are going to go, these are going to make my 3x3s, but I couldn't couldn't stack them up for some reason. There's something wrong on the corner where I'd miss it, and otherwise I'd have too much on my recut pad.
But actually, and then in here we're going to call it
hold section. Right now.
So there's still
she's down, but with this setup for this order anyways, it's a little bit more conducive to just work the bay like this.
So magically this is going to make...
So I'd split this off, I'd throw that one up there, that one up there. Those are my singles. Anything that's good where I know I'm going to make that goes into that pile, or goes into single cutters for smaller pattern later, one-by-one stuff, just stuff that really doesn't work. It's got jacked or cracked or something in it, front of the block, back of the block.
Back with that to make you worried for the program.
So that's generally the model with playbook. So as you know, I work in universal field theory and Sun Tzu. So law is what everybody has the same way of thinking. You know, this is how the business economic works. All the sets work the same essentially. You're going to have a pallet setup. You're going to have some level of cut and some kind of repetition on that cut, depending on certain variables that come off. And you have multiple stack dimensions applying with each other and how you got to best calculate this for the most efficient time. So if the set was different, I know that was all premium. You know, we wouldn't bother with separating. There wouldn't be a need to have a backlog, kind of smaller pattern order behind it to support a system like this.
This would be tough.
And how you set up your floor and work your arrangements is a great practice for that. This is essentially chess moves, they're NP problems.
Whoa, no, big time.
In a function where the chess board is set like this. This is essentially chessboard. If you like gravity, there's a little gravity inside of these. Don't pay attention too much about your X, Y's, and Z's. Just make your own grid for it, and then make your own shop for it. You know, so grid works in the shop the same way. They all have pressures and gravities distinguished from certain functions and how they're interacting in the room. This is more quantum gravity. This pallet isn't necessarily moving, but given the particle that might be in multiple places, is going to dictate a different gravity as it's positioned in the entropy of this room. And of course, you got your other power series equations, you got your Nova stroke, this is an air turbulence. They all work with each other pretty well. The STEM equations, again, you know, they're going to break this down for you. A is your first dimension, then you're stacking, and it looks that way in a breakdown like that, as you're stacking, this is kind of where you're at. This is where entropy is at. It can go in many different directions if quantum gravity affects it. We're looking at a different order set. We're looking at what is the next order in line, and how they're going to affect one another. You know, obviously, it might not be directly as it's affected in here. There's going to be other places.
Go on.
So again, that's generally the setup.
I'm with you.
You know, and it's good to have master plates. So somebody come through, grading the stock as you're doing, you know, kind of looking at your finished cuts. You know, if I'm looking at the stock like that, that's going to determine a lot of timelines. What should I expect hang up outside of it? You know, why is it not the absolute maximum percentage?
You know, for us, if you're running the diagrams
that
way I've
system
been
should have. Why does the little guy not work the gate as efficiently as he can? Because there's a lot of memory behind certain steps. Well, in A mechanics, they just work one step. And at the end
breaking it down like
this, and then the gate opens, the particle goes through, comes down. You can generate a little energy off of that because the entropy is changing. I got all the particles over here. It may look like this at the end of the day, but that generates a lot of energy. That generates a lot of this motor, this machine, to conduct work into the next step.
We cursively call these things, but those are different subproblems.
Couple minutes here.
Those later. And then the work that's actually done by this recurrence is a single addition.
And those are important skill bases. You know, all of them have them. The saw has them. A thermaler's position has them. A manager's position has them. And they're all based in the same mechanics with different horizons. You know, everybody's going to be looking at it from different perspectives. But if you're coming in here looking like a G, you're going to look at this rock, you're going to know that's going to take certain timelines, certain things. Is this person prepared for that? Is this set ready to go? You're going to need to turn out that pallet. You're turning out that pallet because I'm telling you to turn it out, because that's the way I want it to look.
Let's forget about dynamic programming for a moment and go back to...
You don't know what I know, Jimmy. Things I've seen.
Word RAM model implementation. A question.
Yeah, so we're just chasing out the tail end here. I'm not going to throw any cuts up for you, show you anything. This is
stock
beyond thermal and beyond rock facing, beyond landscaping or high-end art.
pallets. I can slide it down.
That is some of the basic techniques that you'll need. Even artists got to prep their stations. They got to have a good environment, even if that environment's chaos.
Mixing all orders together of pieces, going this and then changing that quickly.
So work on your maps, work on your skill chart. Hey, it starts with notes, you know. Gonna get your cut logs, how to design that, how to set that up, what's that look like for the floor.
Sun Tzu, Monty Poly, Cyphers,
you know, I don't know, you might work at McDonald's or have a
Strong
tech
Edge
reason.
Mountain,
You
steady
want to
the
know some of that
forest.
stuff and the ability to set it up in timelines and functions. You know, just practice them out, get them down, get enough of it, get some mass, and then do it again. Start over. Do it again. Start over. Make it a little bit cleaner, a little bit tighter, a little bit nicer, and see what it can do for you. Don't like it? Do it again. Do it again. Just repetition, just like a abruptly long sequence of reciprocating terms.
Vermont's AX
plus BX equals CX, or into Beals, dimensionally AX plus BY equals CZ. Based in an air turbulence equation, but you can also start with the Yang-Mills mass gap problem. This is a physics problem. It's a mass gap in coordination to the NP problem, how applying scientific mathematical symbols in this algorithm, which can change to be specific models, can be causally B mechanics in an algebraic A equals B functioning model. They're basically notes as you break them down. Have a very in-depth note-breaking schedule.
Probably those pallets.
If you like A, B, C, follow that function every single time and can work the dimensions parallel, I don't need all that extra stuff, I just need the cliff points. But if you need one that's really in-depth and broken down, you'll know where to put it, you'll know how to function it, because they basically work the same way. I can't put all the points on here, but I can put enough of them in here where it's going to gain momentum. It's just going to take off from those basic principles. And basically, this is your trainer's model, but it's also law. I got to figure out how this set works. I'm memorizing some things that I did in there to kind of backlog how these will go, how that system will work, analyzing the models, and that's what STEM's about. So you got to stay on those points. They're all your plants. Let them grow. Harvest them when they're ready. Make it happen.